Some aircraft are built to fly faster. Some are built to fly farther. This one, according to those who studied it, was built to challenge the idea of what flying even means. And that contradiction is where the story begins. In the late 2000s, deep inside a restricted test range in the Nevada desert, a classified aviation program entered a phase that would later unsettle even its own engineers. Officially, it was described in paperwork, with language designed to be forgotten. An advanced flight systems evaluation, one of hundreds that cycle through classified budgets every year. Nothing in the name suggested significance. That was intentional. The aircraft itself arrived quietly, before sunrise, shielded by tarps, escorted by procedure rather than ceremony. No insignia, no tail number, no visual markers to anchor the eye. Those present later described it not as intimidating, but strangely unremarkable, shaped to avoid attention rather than command it. Its surface wasn't painted in the usual sense, nor bare metal. Panels met without fasteners. Seams could barely be felt, only sensed as subtle shifts in temperature beneath a gloved hand. From the outside, it looked like restraint. From the data, it did not. The first phase of testing never left the ground. That alone was not unusual. Many advanced platforms spend months, even years, undergoing power and systems evaluations before flight is ever considered. What drew attention here was not performance, but behavior. Baseline measurements refused to settle. Sensors measuring pressure, temperature, and structural strain showed values that were always almost correct, drifting by margins too small to trigger alarms, yet too consistent to dismiss. Overnight readings leaned slightly out of alignment, then corrected themselves without intervention. It was the kind of thing engineers are trained to ignore, until it repeats. When ground power was applied, observers reported a faint metallic taste, not strong enough to be alarming, but persistent enough to be noted privately. Vibrations appeared beneath the hangar floor, not sharp or loud, but deep and steady, like distant machinery operating underground. Tools left on carts shifted positions by millimeters between checks. Dust gathered where cleaning had already been done. Nothing violated safety limits. Nothing demanded an abort. On paper, every run was clean. Inside the hangar, however, space itself began to feel unreliable. Distances measured correctly, but felt longer when walked. Doorways appeared square, yet brushed shoulders unexpectedly. Cooling patterns on the airframe formed asymmetrical gradients that should not exist in open air. These observations rarely entered official logs. They lived instead in margins, in memory, in the careful silence of people who understood how questions can end careers. The team assigned to the program was deliberately small: Air Force personnel, defense contractors, and a handful of specialists whose backgrounds were never discussed. Conversations stayed procedural. Nobody joked. Nobody speculated aloud. It wasn't fear that enforced the quiet, but something more subtle: the sense that the system itself noticed attention. During extended power runs, the aircraft's readings showed another anomaly. Independent clocks across separate systems began to disagree by fractions of a second during power transitions, then realign afterward. Hardware was swapped. Control tests were run using other platforms. The discrepancy appeared only here, always in the same direction, always under the same conditions. That pattern mattered. Engineers are trained to trust boredom. Stable systems are dull systems. This one refused to become boring. By the end of the first week, minor physiological complaints began circulating quietly. Headaches, dry sinuses, Brief disorientation. Nothing severe. Nothing reportable. Birds avoided the airfield on test days, leaving the sky emptier than usual, even for a place already defined by absence. Slowly, an unspoken understanding took shape. This was not simply a vehicle being tested inside an environment. The environment itself seemed to be part of the test. And if that was true, then the real limits being explored were not written anywhere yet. Which raises an uncomfortable question. If this aircraft wasn't just responding to commands, but subtly reshaping the space around it, what exactly were engineers standing next to every day? And how close was too close? Every test program reaches a point where familiarity should bring comfort. By the second week, routines usually settle in. Systems stabilize. Anomalies fade or reveal themselves as errors. This one did neither. From the outside, daily operations looked unchanged. Badge scans, long walks across sun-baked concrete, briefings stripped of anything unnecessary. The aircraft remained covered when not under inspection, positioned in the same hangar, centered precisely on the floor, as if alignment itself mattered. But the numbers refused to rest. Baseline readings continued to drift overnight, small enough to remain within acceptable margins, yet consistent enough to suggest intent rather than noise. Engineers recalibrated sensors repeatedly. Wiring was inspected. Independent verification systems were brought in from elsewhere on the range. The results followed the aircraft, not the equipment. When the platform was rolled out for inspection, its surface revealed more inconsistencies. Thermal readings showed cool zones where heat should have equalized. Gloved hands detected subtle temperature differences across seamless panels, even after hours of inactivity. Inside the hangar, air circulation behaved oddly, as if space itself resisted smoothing out. Measurements told one story, bodies told another. During extended power runs, the metallic taste reported earlier returned more strongly for some personnel. Teeth hummed faintly, not painfully, just aware. Vibrations deepened underfoot, slow and even, like pressure building without sound. Noise levels stayed low. Heat signatures remained modest. Structurally, the aircraft appeared calm. The contradiction became difficult to ignore. Dust appeared again, pale, fine, almost chalk-like. It collected along the hangar floor beneath the airframe and clung to lower surfaces in patterns that did not match airflow or movement. Maintenance crews swept it away without comment. When asked, they blamed the desert. The explanation fit poorly, but no better one was offered. More troubling were the timestamps. Independent systems disagreed during power transitions by fractions of a second, then corrected themselves. Engineers checked clocks. They replaced units. They ran parallel tests with other aircraft under identical conditions. Only this platform produced the effect. Always during ramp-up. Always during ramp-down. Patterns like that suggest feedback. One contractor with decades in propulsion quietly remarked that the power system did not behave like an engine in the conventional sense. He described it instead as a condition, something that established a state rather than producing thrust. The comment was never repeated. The following day, he was reassigned. His desk was cleared before lunch. Security procedures tightened soon after. Badge scans increased. Escorts appeared where none had been required before. Phones were banned outright, even powered-down ones. Medical staff became a visible presence during runs, positioned not near the aircraft, but near the people. Observers began to feel less like witnesses and more like variables. One afternoon, during a routine calibration with the aircraft completely powered down, Engineers noticed the clocks drift again. No power, no data flow, no mechanical reason for change. The test was repeated. The result held. The hangar felt quiet that day, yet a faint pressure still seemed to press upward through the floor, like an echo that never fully faded. Someone stood longer than necessary near the fuselage, staring, before stepping away without explanation. Health complaints grew harder to dismiss. Headaches lasted longer. Sleep became fragmented. A technician briefly lost consciousness during a night shift and woke disoriented. Medical logs attributed it to stress and dehydration. Water intake increased. The schedule did not slow. What changed most was conversation. People spoke less about the aircraft and more about procedure. Weather became a favored topic. So did schedules. Whenever discussion drifted too close to behavior rather than performance, silence followed. The unspoken rule was clear. Describe what it does, not what it feels like. Yet the feeling persisted. Data suggested the aircraft was doing more than reacting to inputs. Some changes appeared in sensor readings just before commands were issued, within margins small enough to dismiss, but consistent enough to track. Engineers debated feedback loops and prediction algorithms, but nothing fit cleanly. By the end of the second week, it was becoming difficult to avoid a deeper implication. If the aircraft was not merely responding to control inputs, but anticipating them, then measurement itself was no longer neutral. Which leads to a troubling question. What happens when the act of observing a system begins to influence how that system behaves? And how long before the observers themselves become part of the equation? There is a quiet moment in every test program when attention shifts away from the machine and toward the room it occupies. That moment arrived without announcement. The third phase was still officially ground-based. No flight, no taxi. Just sustained power at levels higher than previously authorized, held long enough to observe stability over time. On paper, the risk profile remained acceptable. Structural margins were generous. Thermal limits were untouched. The language of the briefings stayed calm. Inside the hangar, the atmosphere changed almost immediately. As power levels increased, the familiar metallic taste returned faster than before, coating the mouth and throat with a sharp, dry sensation. Vibrations deepened, not louder, but heavier, pressing through boots and into the chest. The sensation was often compared later to standing near a massive electrical substation, buried underground. Steady, impersonal, indifferent. Instrumentation stayed green. Timestamps, however, did not. Clock drift increased in magnitude, no longer smooth but stepping forward in tiny jumps, followed by pauses, then more jumps. Independent systems aligned perfectly for short stretches, then slipped apart again. This kind of agreement should have been impossible. Systems designed separately are supposed to disagree, not synchronize. Engineers logged everything. The air inside the hangar began to feel thicker, harder to move through, as if space had gained resistance. Lighting levels did not change, yet fixtures appeared farther away, like depth itself had softened. People slowed their movements unconsciously, testing distances before trusting them. A shoulder misjudged a rack. A hand reached too far, or not far enough. No one said anything. The pale dust returned in greater quantity. It lifted from the floor in slow curls that ignored airflow and ventilation patterns, gathering along the aircraft's skin. As it traced the surface, outlines emerged, lines and contours that did not match any visible structure. For brief moments the aircraft appeared more complete, as if something extended beyond the metal. Then the effect faded. Midway through the run, a technician near the forward section lowered himself to one knee. Not a collapse. A controlled surrender of balance, as if gravity had renegotiated terms. Medical personnel guided him out. He remained conscious, eyes fixed on the aircraft, unable to recall the last several minutes once removed. Shutdown was ordered earlier than planned. As power stepped down, the vibration eased reluctantly, fading slower than it had risen. The metallic taste lingered longest, like a memory that refused to clear. When silence finally returned, the hangar felt hollow, as though sound itself had been carried away. Data review afterward revealed something unsettling. Small changes in sensor readings appeared just before control inputs were logged. Not enough to trigger alarms, not enough to prove intent, but enough to suggest anticipation rather than reaction. Engineers searched for software explanations, predictive algorithms, adaptive control loops, hidden feedback paths. None accounted for the timing. The system wasn't guessing ahead. It was already there. Security protocols shifted again. Fewer people were allowed on the floor during runs. Briefings shortened. Questions narrowed. Medical staff stood farther back, watching personnel more closely than equipment. The feeling of being monitored deepened, though cameras were never blamed. Late one evening, a closed meeting was called. No slides, no handouts, just words, chosen carefully. The next phase would involve higher energy states and reduced human presence near the aircraft. Risks were acknowledged, managed, not described as safe. When asked directly about the clock drift and environmental effects, the response was brief. Some systems, the director said, do not like being measured the same way twice. That was the closest thing to an explanation anyone received. Walking back across the darkened range afterward, the desert felt wider than usual. Stars appeared sharp and distant, like reference points rather than comfort. Watches were checked more than necessary. Time itself had become suspect. By this point, it was clear the program was no longer testing performance alone. It was probing boundaries. Boundaries between machine and environment. Between observation and participation. Between control and influence. And once boundaries are tested, they rarely return unchanged. Which raises a critical question. If the environment itself was now reacting to the aircraft, and measurements were bending simply by being taken, what would happen when the system was pushed beyond observation and into motion? The fourth phase began without ceremony, which made it more unsettling than any countdown ever could. One morning, personnel arrived to find the hangar stripped down to essentials. Fewer carts, fewer tools, fewer people. The aircraft sat centered on the floor under hard, even lighting, uncovered and unremarkable at a glance. Power cables were already laid out. Medical staff stood farther back than before, alert and silent. This phase focused on sustained energy states, held longer than any previous run. The goal was not performance, but endurance, to see how the system behaved when it was allowed to remain active, unhurried, unchallenged. On paper, the configuration was conservative. Structural stress remained low. Thermal readings stayed flat. As power ramped up, the familiar sensations returned with urgency. The metallic taste struck fast and sharp, strong enough to make eyes water. Vibrations climbed deep into the chest, steady and insistent, like pressure building inside bone rather than air. The hangar floor no longer felt passive. It felt engaged. Data began to drift within minutes. Timestamps slipped more than before. Independent systems that should never align did so perfectly for short intervals, then diverged again. External range instrumentation struggled. Radar returns softened and sharpened unpredictably, as if the aircraft were choosing how clearly it wanted to exist from moment to moment. Optical tracking showed shape without depth, flattening the image in subtle ways. None of it violated rules. It only bent them. Movement inside the hangar slowed. People tested space before stepping. Distances felt unreliable. When someone stood to stretch, they misjudged the reach to a rack and struck it harder than expected. Others noticed and adjusted, saying nothing. The pale dust rose again, heavier now, lifting from the floor in slow spirals that ignored gravity and airflow. It gathered along the aircraft's surface, tracing lines that made no structural sense. For a moment, the outline of the platform appeared different. Not larger, not smaller, but more complete, as if the visible airframe was only part of what occupied the space. A technician near the forward section lost strength in his legs and sat down abruptly. Medical personnel moved in quickly. He remained conscious but could not recall the last several minutes. His gaze never left the aircraft as he was guided away. Shutdown was ordered early. This time, the system did not respond immediately. Power levels dropped in steps that did not match commands, holding steady between changes as if resisting interruption. When silence finally returned, it felt imposed rather than natural. Post-run analysis deepened the unease. Patterns were clearer now. Data changes appeared before inputs were logged. The aircraft was not simply responding faster than expected. It was behaving as if it already knew the sequence. Engineers checked for hidden automation, predictive software, unauthorized updates. Nothing fit. This was not anticipation coded into software. It was behavior emerging from the system itself. Security responded quietly. Access tightened. Conversations were monitored without being obvious. Medical checks increased, framed as precaution, but felt like inventory. Personnel began to understand they were being evaluated alongside the aircraft. In a closed discussion later that day, leadership acknowledged the anomalies without naming them. The next phase would involve altered power sequences and reduced human proximity. The language shifted responsibility downward, careful and legal. Initials were required, signatures followed. The implication was clear. The program was moving forward not because everything was understood, but because stopping now would raise more questions than continuing. Control, once assumed, was becoming a variable to be measured. And variables, by definition, can change. Which forces an uncomfortable question. If the platform could influence space, time, and behavior without ever leaving the hangar, what would happen once it was allowed to break contact with the ground? And would anyone be prepared for what followed? Flight day arrived wrapped in routine, and that was the most deliberate decision of all. There were no speeches, no emphasis on milestones, no language that might invite reflection. On paper, it was a limited envelope evaluation, a controlled departure, short duration, unmanned, supported by range instrumentation and a chase aircraft for verification. Filed that way, it looked like dozens of other tests that had come before it. The desert morning was clear and cold. Groomed emptiness stretched across the dry lake bed. From a distance, nothing about the aircraft suggested what it had already done to the people who stood near it. As ground power transitioned to flight configuration, the metallic taste returned slowly this time, almost politely, like a reminder rather than a warning. Vibrations spread outward, not loud, not sharp, but deep, pressing inward instead of radiating away. Screens stayed calm. too calm. Taxi tests proceeded without incident, if incident still meant anything measurable. The aircraft moved with a smoothness that caused ground crews to pause, recalculating distances with their eyes. It stopped exactly where planned, lined up on the runway, with a precision that felt rehearsed. When the takeoff sequence began, something felt wrong immediately. The aircraft left the ground early, not abruptly, not dramatically. It simply separated, flatter than expected, as if lift were optional rather than earned. Load sensors showed almost nothing. Structural stress stayed low, unconcerned. Every aircraft ever built pays a price to leave the ground. This one did not. As it climbed, the range began to disagree with itself. Radar reported one position, optical tracking reported another. Passive systems showed a soft distortion trailing behind, not heat, not wake, but a bending of background that made straight lines seem tired. The chase aircraft pilot reported a visual that matched none of the feeds. He described the platform as present but difficult to judge, as if depth itself had been reduced. His voice remained professional, but strain lived just beneath it. Then the aircraft turned, not sharply, not fast. It pivoted through a curve that violated the planned envelope without registering as a maneuver. Load stayed low. Control remained smooth. The data suggested the air itself was cooperating. Telemetry dropped, without warning. No alarms, no cascading failures, just silence. Clocks kept running, seconds stretched. People counted without meaning to. When data returned, it arrived disordered, timestamps overlapping, streams misaligned. The aircraft appeared farther downrange than it should have been. Not by much. Enough to matter. Abort orders were issued. The aircraft did not respond immediately. It held its course, steady and calm, as if finishing a thought. Then it turned back, lining up with the runway from a position it should not have known how to read. The return path crossed a boundary marker, not included in any flight plan. On approach, heat shimmer appeared where no heat should exist. Folding inward, cold-looking, wrong. Touchdown was light, smooth, almost casual. The aircraft rolled to a stop as if landing were an afterthought. When it came to rest, the vibration faded slowly, reluctant to leave. The metallic taste lingered. No one spoke. Recovery crews waited for clearance, longer than usual. As the aircraft was towed back inside and the hangar lights rose, something was missing. A panel marker visible on takeoff, no longer registered. No alerts, no damage flags, just absence. Inside the hangar, the truth became visible. A section of the aircraft's skin was gone, removed cleanly. Behind it was not wiring or structure, but a smooth cavity, dark, cold, with frost forming along its edges and melting upward. That was the moment the program stopped being about flight. Security closed in quietly. Gates locked without alarms. Phones were collected with calm hands. Medical teams moved not toward the aircraft, but toward the people. Separation followed. Waiting rooms, briefings without windows. Official language would later describe the flight as nominal. Those who were there understood something else. They had not just tested an aircraft. They had tested how far confidence could stretch before control became a courtesy rather than a fact. And that leaves one final question. If this platform could leave the ground, alter space around it, and return changed without violating a single formal limit, how many other systems are already operating beyond our rules, simply waiting for the moment we let go?